Welcome to EELE 261, Introduction to Logic Circuits. My name is Brock LaMeres and I will be your instructor during this course being offered during the summer of 2024 by Montana State University. The goal of this video is to give you an orientation to the course, introduce myself, and then look at the logistics of what we'll be doing in terms of what activities you're going to do, where to find them, what's graded, and how you will actually turn everything in. So at the end of this video, you'll be able to engage with the course. So let's get started. This course is the first in a series of courses where you learn about what a computer is. So a computer is a device that operates on information that is stored and manipulated in what we call binary, or ones and zeros. You probably have heard of a computer operating on binary. All a 1 and a 0 is essentially a true or a false or an on or an off, and that's what we call logic, okay? And so a logic circuit is something that only operates on inputs that can take on a true or a false or a 1 or a 0 and output a value that is either a 1 or a 0 or a true and a false. So that's what a logic circuit is. And it turns out that logic circuits are the building blocks of all computer hardware because a computer in itself is a digital device or a logic device. Now, a computer is a collection of hardware and software. And the hardware of a computer is designed to execute a predetermined number of instructions. So these are already built into the computer hardware. We provide what instructions are going to be executed and in a particular order to the computer hardware in order to accomplish a task. And so a computer is a collection of hardware and software where the software is nothing more than the list of instructions to execute and in what order. Now, computer hardware takes many forms. It can be laptops and desktops. It can be servers. It comes in PC and Macs. It comes in, iPhones and Androids, and that's fine. But it's all the same stuff. It's all ones and zeros being acted upon by logic circuits. So in this class, what we do is we start at the very beginning. We start looking at the most basic logic circuits there are, which are called logic gates. And these are simple things like if you invert the input. So if it's a 1, make the output a 0. If the input's a 0, make the output a 1. And we build up more and more complex circuits to the point that we can then take on more advanced classes where we put the circuits together and actually build a computer. But we are in this class looking at the low-level hardware that sits beneath the hood of an actual digital computer. We are not looking at the software that is used to tell the computer what to execute. Okay, so that's what this class is about. It's like I say, you won't know exactly what a computer does at the end of this class, but you'll have the start so that you can take on the follow-on classes that do teach you what a computer actually looks like underneath. Okay, so the topics that we cover in this course to learn about computer hardware consists of 7 modules, and the modules represent an individual chapter in the textbook, but we don't call them a chapter in the course, we call it a module because it's both a chapter in the textbook, an associated set of videos, an associated set of homework assignments, and an associated set of laboratories. So all together we call it a module. And we cover 7 modules or corresponding to the first 7 chapters in the textbook. So we start off with just a really short module, just kind of get used to this notion of what is a digital signal. And we do that by contrasting it to an analog signal, which we might be more familiar with. Then we move into number systems, and we talked about how a computer operates on ones and zeros. So in order to understand how to build circuits that manipulate ones and zeros, we need to understand how you represent information with ones and zeros. And so we learn about how to convert a decimal number into its binary equivalent, and we learn how to do binary addition and binary subtraction, and learn how to represent binary numbers in different codes to represent positive and negative numbers, and in addition to using other number system bases in order to represent large numbers of ones and zeros. Once we get that, we turn to module 3, which is where we actually start looking at the most basic, what we call gates, or the most basic digital logic circuits that we have. And we look at these gates at the circuit level. So we actually realize that even though the inputs and outputs are ones and zeros, They are circuits. They need power, they need ground, these are parts that we can buy from the stock room. We're actually going to put these parts down on a breadboard and we'll wire them up and we'll look at the inputs and the outputs and see how they operate. Once we have that covered, then we turn to module 4, which is where we actually start learning how to design what we call combinational logic. So we start taking a description of a circuit and saying for these combinations of ones and zeros, the output should be ones for these and zeros for those. And then we learn how to actually synthesize or create a logic circuit that can accomplish what we wanted. And we call it combinational logic design because combinational means the output of the circuit is based solely on the instantaneous input of the circuit. Okay, so there's no storage in it. It's essentially a left or right circuit. Then what we do is we move into module 5, which is where now that we know how to design a logic circuit, we kind of take a different direction and we start learning about a hardware description language. So it turns out that while we learn about how to design logic circuits on pen and paper and we actually can breadboard them and wire them, logic circuits get really big really fast. And so it becomes impractical to be able to model a modern digital system on paper using schematics. So we've invented this thing called a hardware description language, which is a programming language that allows us to describe the functionality of a logic circuit. And that's really cool because we can describe it using text, meaning that we can describe very large systems using just alphanumeric characters. In addition to, since we're describing the functionality on a computer, we can actually perform simulations of the computer or of the description in order to verify that it's accurate. And then once we have an accurate description of what we want, we can run it through another software tool, which is called the synthesizer. And the synthesizer will actually create the logic gate schematic for us. So it'll actually pump out the final schematic that we could then build with our breadboard, or in turn, actually put it onto what we'll learn about is called a programmable logic device. So that's one of the parts that you have in your lab kit. And so this allows us to essentially design logic circuits by typing at a keyboard, which is how you'll do it in industry. But we had to get to module 5 in order to actually even know what a logic circuit was and then how to actually create something. In module 6, we get a little bit of practice designing very common combinational logic circuits, which we call MSI logic. It just stands for medium scale logic. It's just medium just means a little bit bigger than a very simple logic circuit. And so we go through a series of learning about various MSI logic circuits, and then we model them in our HDL or our hardware description language, and then we actually implement them or download them onto a programmable logic device and test them. And the V in module 5, I always say HDL, but the V is a particular language. So it's VHDL. It's one of the 2 logic description languages that are most common in the world right now. And then we finally wrap up the course with module 7. And this is on sequential logic. So this sequential logic refers to a circuit that has some elements of storage to it. And so we're not only going to have combinational logic circuits, but we're going to have devices that can store ones and zeros. And what this allows us to do is make a more intelligent circuit because we can base the outputs of the circuit based on current inputs and also past values of inputs. And we culminate the class with this very powerful logic circuit, which is called a finite state machine. And we'll actually build that in hardware. So before we get started with the logistics of the course, I wanted to give you an introduction to myself because I will be the voice and the hands and all the videos that you'll be watching throughout the summer session. And it's kind of good to know who the instructor is. Sometimes in an online class, you can feel a little disconnected, especially when I don't have the camera on myself. So it just sounds like some random voice. So I want to just introduce who I am and give you my background. So again, my name is Brock LaMeres. You can call me Brock. I am a professor at Montana State University in the Department of Electrical and Computer Engineering. And I've been at MSU for 18 years. Prior to that, I worked in industry for Hewlett Packard or HP for 8 years, where I worked on digital test equipment for the computer industry. I actually got my bachelor's degree in electrical engineering from Montana State University back in 1998. So I went to Colorado and worked for HP for 8 years, where I was a design engineer, where I worked on teams where we designed test equipment for the computer industry. So our customers were Intel and IBM, and in that position, it was really cool. I got to learn a lot about the computer industry and see how the hardware and software of a computer play off of each other and kind of spur innovation in one versus the other. You got to make the hardware more higher performance to run the new software, and then as it gets faster, the software can become more complex, and just how that whole industry works. And so my specific focus was logic circuits, so I designed digital hardware, many of the circuits that we'll be covering in this class. And then I also did, printed circuit board design and high-speed digital stuff. Since I worked for, a large company, they would pay for me to take classes to get my master's degree and PhD. So I chipped away on that nights and weekends and at the University of Colorado. And I worked for, it probably took, 6 years to get my PhD. And then I taught some classes at the University of Colorado and kind of fell in love with teaching. And then decided, hey, why don't I become a professor? And so then I came to MSU. And at MSU, what I do here is my area of passion is computer engineering. And so I teach classes in that area. So anything to do with computer programming, computer hardware, computer engineering. If you take these classes, I'll be involved in them. And then I also do research in the area of computer engineering. So a little background on my research. When I came to MSU, I was looking at a way to basically come up with new computer architectures to make computers better. And that's a very broad statement. So you kind of look at what specific needs there are in different industries. And I discovered this kind of niche where NASA was looking for computers that could operate in the presence of space radiation. And I don't know anything about radiation, or didn't at the time. But it turned out that the type of radiation they were concerned about was the type that just causes bit flips. So ones and zeros flipping and causing computers to crash. And so I was like, well, I can do that. So I came up with this idea for a computer that had just all these different fault detection and recovery mechanisms. And we ended up calling it RAD-PC. And it was really cool. So for the past 16 years, I've had funding from NASA to basically build prototypes of this and fly it in different environments. So we've been able to do all sorts of things. We've flown it on, we've gone to the International Space Station. Sorry to make you car sick. I'm sitting here. I want to scroll down and to the beginning. So we've done everything from sounding rockets, where we put the little computer in a payload and shot it up on a missile, and then it comes right back down. We've done satellites, where we've built little satellites and put it in the satellite and sent it to the International Space Station and pushed it out. We've done internal on the International Space Station. We've done balloon flights of this. Here's another one coming out of the surface, or out of the space station. And we got selected last year to go to the surface of the moon. And so this computer, this is going to be one of the biggest projects that MSU's ever had in its history, will actually go to the moon and operate en route to and on the surface of the moon. And we've actually delivered the payload. I'll show it to you because it's just awesome. So this is what it looks like. It's a little computer that sits in this payload right here. And I'm going to scroll down here. This is a picture of it on the International Space Station getting installed. Let me scroll all the way to the bottom. This is what the computer looks like. This is what the payload looks like that'll go to the moon. And this is what the lander looks like. So this is a mock-up, but the real lander is actually almost built. And our computer will go right there where that little box is. And this thing is going to launch on a SpaceX rocket in end of this year, and it'll take 45 days to go to the moon. We orbit Earth a bunch of times, getting further and further out each time, and then you plop down on the moon and we'll operate. And so this has been just an awesome experience. This is a patented computer as of actually this week. We just got issued a patent on RAD-PC. And I've started a company to spin this out. So one of my former MSU students are working on this thing, and we've got a series of contracts with NASA to bring this to market. And so that's kind of my technical side of things. And The reason I tell you that is because then that influences the teaching. Because what I've done is over the years, I've written a series of books that are essentially what I feel that students should know in order to have the skills to work in my research lab and also go on to work in industry. And so as you take more courses, you'll notice you're going to be reading out of the book I wrote, this Introduction to Logic Circuits and Logic Design with VHDL. The introduction to logic circuits is the class you're in. Logic design is the next class you'll take. And so in VHDL is the language you're going to learn. And so I have all these books that I've written over time. And so I say that because I want you to know that I'm just not some random person off the street that saw this job opening and applied to it and using other people's material. This is my passion, right? I love computers. I love computer engineering. I've worked in industry as a computer engineer. I've gotten my PhD in computer engineering. I do research for NASA. I've started a company in this area. I write books in this area. This is what gets me out of bed in the morning. I love all aspects of this. And I'm excited to share any of the knowledge that I have in hopefully to motivate you to continue your education to learn more about computers. Because I'll tell you what, computers aren't going away. They're going to be in every aspect of our lives. In 10 years, every single human will need to interact with a computer in a different way than they do right now. And that will probably involve some sort of programming the computer. And so I'm excited to work with you this summer. And so that's kind of my background. And now let's switch over and talk about the logistics of the course. All right. So it all starts with Brightspace. Okay. So Brightspace is what we call the learning management system, which is basically just a website. But the website is ecat.montana.edu. So you go to that, you log in with your net ID and password, and then if you've never used Brightspace, you'll be brought to this landing page, and it just has system announcements. But over on the right, you'll see this list of my courses, and so you can come into here and you'll see the courses you're enrolled in. And so what happens in Brightspace is that along the top you have all the tools that you're going to use, content, discussion, etc. These are all the main tools. And what I do in my course is every week I'm going to have an announcement that sits here, and it'll tell you roughly what we're going to work on. And it's just, it gives you an orientation of like, okay, I'm in the right spot. What am I working on this week? And so week 1 activities, you have this announcement, you have a picture of this pretty awesome cover, in my opinion. And then it gives you a little snip of what's due this week. So you're going to see we're going to have a whole lot of assignments that are due in this course, and they're not all worth a lot of points. So we're going to have a lot of low stakes activities for you to learn. And so you see this thing, you kind of get oriented to where you're at. Then what I do is that everything is in content. Okay, so that's really the only place you need to go is if you go into content, you see all the pages for every module in the course. All right, so you have course information and syllabus, module 1, module 2, etc. When you click on these are pages, and what I do is I link everything on these pages. And what I mean by that is that sometimes you'll click on a link and it'll take you to a file. Sometimes it'll take you to a YouTube video. Other times it takes you to tools within Brightspace. So for example, you can click on quizzes and go see all the quizzes we'll take, but I link them in the content page. So that way you don't have to worry about like, well, do I have to look in quizzes or on content? And it's like everything's in content. Same thing with assignment folders. Assignments is where you upload files. You don't have to go dig through the assignment tool and figure out what's due and where do I upload it. It's like, no, everything's linked in content. So all you really need to remember is that the content is where you do everything, or where you find everything. Okay, so when you come in here, I give you, the course syllabus is obviously something important. So we'll go through that in a second, but I'll just kind of show you the highlights here. So I'm the instructor. I list this here so that you have the links to the content information. This is a fully online class. We have no scheduled meeting times. We do have weekly deadlines, which we'll look at, but there's no times where you have to log in and interact with us. So if you need help though, we're here. Like I'm working, like this is my job. And so we also have a teaching assistant, Caleb, that is going to be, he's working too. And so what we're going to do is we're just going to use WebEx video conferencing to schedule, to talk. So if you ever you're stuck on something or you want to talk, you just schedule an appointment and we jump on a meeting and we're rocking and rolling. Okay. So as you go through this, email is really going to be the primary form of communication. So since email is so important and this is what you do as an engineer, I actually give you an opportunity to earn some extra credit by learning about professional email etiquette. So, and you can send me an email and get a few extra points. The material for this course is basically, it's online, so you need a computer. You can't run a Mac. Okay. So if you're going to be an engineer, just get rid of your Mac right now. I'm telling you, everything runs on Windows. It also runs on Linux, but everything is really moving to Windows. Okay. If you have a Mac, your life is going to be harder. Okay. You're going to have to dual boot it and you're always going to have to do more work to accomplish the same thing as everybody else using the right tool for the job, which in this case is Windows. So just throw it in the garbage and just stop the pain. If you're going to be an engineer, just switch over to Windows. Okay, everything's going to be easier because all the tools run on that. Then you need a textbook. Amazon's the best place to get it. Yeah, 3rd edition, but you can, if you have the older ones, go ahead and do that. Then you are going to check out a Digital Logic portable kit. This is how you can do all the labs. So you're going to pick this up in the ECE office starting May 8th, or if you don't pick it up, we'll ship it to you. Okay. But you're going to need this right away. And so this is going to have all the parts that you need. You're basically going to design and build circuits on a breadboard, and you're going to use a portable instrument we give you to power your breadboard and to measure things on your breadboard. And then you're going to demo your labs by using a camera and just take a little video of it. So you'll just take your phone and take a video of, you flipping switches and making LEDs light up and doing the proper logic. And that's how you're going to demo the labs. And so the lab stuff is totally portable. You just power everything off of your computer and you can do this class anywhere in the world. Okay. All right. So if I look at this, if I go to the next kind of part here, you start seeing like what it looks like for a normal module. So you click on module 1. This is how they're all laid out. We start with what are you trying to learn in this module? And then everything's linked in here. So I try to do these bold things that are kind of like the call to action of what you specifically do. So for this section, it's like read this, watch that, do this. And these links then walk you through everything that is needed for this particular section. Same thing here, read, watch, do. Then you got your laboratory, read, watch, do. Okay, but everything again is linked in here. This class is basically, you're going to watch YouTube videos, you're going to do homework in the form of multiple choice quizzes, and then you're going to do a lab, which is building circuits, taking a video of it, and uploading it. And then at the end of each module, there's a little quiz that you'll do. And this flow is how the whole course will go. There's 7 modules. They all look exactly the same roughly. And that's how this whole course is going to go. So if let's go over to the syllabus and go through this. The syllabus, we've talked a lot about this, but here's the learning outcomes of the class. It's funny to cover learning outcomes at the beginning of a class because you probably don't even know what many of these words are. So at the end of the course, you should come back and look at what we were trying to teach you and then go, oh yeah, I know what that is. I am located in Bozeman. I'm in Norm Asbjornson Hall. But again, you'll probably never see me live unless you're in Bozeman. You don't have to be. But my contact information is on here. This course runs for 12 weeks. We start on the 13th of May and we end on a Friday, August 2nd. And it's fully online, okay? So you don't have to be anywhere, but you do have deadlines. So course website is Brightspace. Office hours, there's no office hours and there's tons of office hours. We don't have anything scheduled time-wise. If you need an appointment, you just email and we'll set up a time to talk. There's me and the TA. Between that, we'll be able to talk to you probably the day of. So don't even worry about that. Again, though, email, almost everything can be handled with email if you wanted to do that. Grading distribution, you're going to have homework, 25 points. Labs are the big one. That's where all the learning happens, 45%. End of module quizzes, these are kind of like exams. They're timed quizzes. And then you're going to have an exam. Okay. All right. So, all right. Now let's take a look at this. You got Grading scales just straight. I don't do minuses or pluses. And academic policies, don't cheat. You say what is cheating? Well, here's the reality. Any problem that we face today can probably not be solved by an individual. So you're always going to work on teams. So I encourage you to work together if you're in a position to work together. And that's just called collaborating. That's how it's done. That's how engineering is done. Cheating is where you just turn in somebody else's work. Okay. So it's where you're like, hey, I didn't get the lab done. Can I take a video of your breadboard? Or can you just give me the answers to something? That's what cheating is. Collaboration is not cheating. Okay. So I encourage you to collaborate, but I don't encourage you to use other people's work. And then the course components in terms of like what this consists of. There's readings and there's instructional videos. I will tell you this. I wrote the book and I made the videos and they're the same material. Okay. I wrote the book first and then I recorded the videos over the slides and the images from the book. So if you like reading and don't like videos, you can read the book and be fine. If you like videos and don't like reading, you can watch the videos and be fine. Okay. So whatever you want to do, both modes are available to you. Homework will be graded and it's due each week, and you can open the homework quizzes. You can put in answers, save it, and go away and come back to it another time. However, there's a deadline, and once the deadline comes, the homework closes and you're done. So you got to submit these before the deadline. Lab assignments are due weekly also, and then end of module quizzes. These are going to be quizzes, but they're different from homeworks, even though they're both quizzes. These ones are timed. So when you have a module quiz, it's going to have a timer. So once you start it, you're going to click, 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 and when that expires, it's done. So you got to get done with it and submit it in the time link. And you can think of it as kind of in-class. It's kind of like the same as an in-class quiz or an in-class exam. And then there will be a final exam at the end of this, okay? Which is just a massive quiz, okay? It's also time. But now this is the most important part. This is the table. Okay, this is the schedule of what you are going to do every single week and what is due and when. So if you look at module 1, what you're going to notice is this. I list out the week that you're in and I list out the modules and the sections of activities that you're going to do. And then over here you see what is graded. Okay, there's homework, labs, quizzes, and exams, and you'll see that there's going to be a graded deliverable for this particular section. Same thing. Homework 1.1, 1.2, there's your graded deliverable. Oh, and then there's a lab, it's graded, and then there's an end of module quiz, it's graded. So you want to really pay attention to the activities you do. They all have some graded aspect to it, and this shows you what is due and when. Now let's talk about when it's due. Everything's due on a Wednesday at noon. Okay. So during the first week, what I want is I want you to engage right away. I don't want you to wait because this class goes really quick. So the first week you will have deadlines that are due on Wednesday at noon. Okay. So you got to get your kit. You got to make sure you're logged in. You got to make sure the software is installed, and you got to show me everything's up and running. That is due on the first Wednesday of the class. All of these module 0 and module 1 activities are due on Wednesday at noon. From then out, the way that the course flow works is the activities you work on during a week are due the following Wednesday at noon. So module 2, which happens to fall within week 1, it's due the following Wednesday at noon. Then you go to module 3, which is in week 2. All these activities are due the following Wednesday at noon. And then this week, the following Wednesday at noon. Why Wednesday? Well, you should, if you're working on this during the week, you should be able to finish all of these activities in a work week. So Monday to Friday. However, if you were working and you decide to do this class on the weekend, you could work on it on the weekend. I don't want to have the deadline Friday at 5 and then you don't even get the weekend. So you do get the weekend. But then it's like, do you want the deadline to be Monday at 8 a.m.? And it's like, well, what if you needed help? And what if me and the TA weren't available on the weekend? Well, we need to give you some time on Monday to get help. And then it's like, maybe Tuesday. So anyway, there's no perfect deadline. So what I do is I just put it right smack dab in the middle of the week. Wednesday at noon is when it's due. The deadlines always have to be during 8 to 5 working hours. Otherwise, for some reason, the computer always crashes if it's outside of work hours. However, just keep that in mind. Even though the deadline is due Wednesday of the following week, you should be able to get done with all your material during the week that it's assigned. So I encourage you, don't get in the habit of waiting until Wednesday, because this is like 10 to 15 hours a week of effort. If you try to wait until Wednesday morning to work on it, you're not going to get done. And we can't extend the deadlines for you just because you didn't work on it until the last minute. Okay. So this is everything that you go, and you just get in this flow of lather, rinse, repeat all the way through. Finally, we get to week 12. You're going to have a comprehensive 3-hour exam, which is a multiple choice quiz. By the time you get to it, it should be super easy. Okay. All right, so that is the syllabus, and that really is it. I mean, this class is going to be a lot of sitting here watching YouTube videos. So if I come out here and I do this, let me make sure this is, oh, you got to watch a little, no big deal. It's only 5 seconds. So you're going to sit here and you're going to watch these videos, and it's me on here just doing this. I mean, this is like the equivalent of sitting in class and watching me write on a document camera or write on a whiteboard. And so there's really no difference. You can't ask questions, I guess, but you can repeat the video over and over. And then if you have a question, just email me or email Caleb, and we'll get back to you right away. Okay, that is everything that you need to know to engage in the class. So at this point, go ahead and do it. Remember, you got deadlines Wednesday of the first week of class, so don't forget to do that. I look forward to working with you, and good luck.